few more graded assignments to hand back. I'll do it during the in-class assignment because we got an in-class assignment today. There's only a few left. I'll hand them back during that time. If you look at the top of the page, you'll see the word okay and a circle around it. That means 100. It was a non-detailed grading, which means I did not look to see what you wrote down. I did not to see if it was right or wrong. I looked to see that you attempted everything with enough work. That's all I was looking for. Some errors stood out, and so I probably circled them or I wrote the word error, but that was just to bring it to your attention. You still got 100 if you attempted every problem with enough work. But don't rely on your answers during the quiz. Use the answers that are posted during the quiz, not these answers, because I didn't look to see if it was right or wrong. So don't rely on your answers. Rely on the posted answers. So that's what's going on with that. That's your first non-detailed grading. Now, your homework this week is due when?
Never.
Oh yeah, sure. Now I get group participation. That's probably the best answer I've heard, because it's something everybody is happy about and something you do remember. Never. Never. So I thought I changed today's lecture. It's a lot different than last semester because they handed in this week's assignment. They didn't get the never there. So what I decided to do, since you're not handing it in, is I'm going to include the homework problems as part of the lecture. We'll do them. And that's exactly where we're going to start today. Anybody's got questions real quick about, let's talk about crude oil. I looked it up it was about 30 minutes ago, 20 minutes ago. 81.07, the three prices. And I'm being more particular on what prices I'm grabbing from Gas Buddy because I noticed some of them are like 48 hours old, and that's not fair to grab a price 40 hours old. So I'm looking like 10 hours or less old in prices, which caused, I think, the prices to go up somewhat a little bit, only because I'm making sure they're semi-recent prices at least. So there's our three prices. I think we started, it was in the $75 to $78 a barrel for crude when we started the class, and prices were like 302 to 305, somewhere in there. So now we're up to 81.07, and the prices are up around 319. There you go. A little bit of, we're just checking it out. Quiz, Thursday. I will email you the rules, the instructions tomorrow, but they basically say no paper can be in front of you other than the quiz and your book. If you have notes you want to use, you have to take a picture of them, email them to yourself, and put them with the rest of the stuff that's all digital. You can open up a picture of your notes if you want to use your notes, but you can't have paper in front of you other than the quiz and a book. That's it. No phones out whatsoever. That's going to be on the instructions. No internet. You can't use the internet whatsoever. So you want to make sure you these seat assignments have all been made when you come in. There'll be a picture of the seat assignment, so you know there's 8 in a row. So just count it off from this end. Figure out where you're sitting. There's 8 in a row going back to, and the last 2 rows, I think the 4th and 5th row have 7 each, I believe. So it's 8, 8, 8, 7, 7. What else? Get everything off the Canvas. All those answers that are posted, the PowerPoints, it's in 2 days. I already wrote it because I was afraid the copy machine may go out of order. There it is, it's 100 problems. I'm just kidding. Not 100. I don't remember how many problems it is. I'll announce that in 2 days. You'll see when you get here. It's not that bad, it's easy. That's all we're doing on Thursdays, the quiz. Once you finish the quiz, you're done, you can leave. You know, I expect you to be done in 10 minutes. So, what? No? That's it. Any questions? I'll send instructions out. You know what to expect. Everything's got to be electronic. No paper for those who just walked in. No paper. All right, let's get to it. Let's start with the weekly instructions. There's 3 assignments, but like I said, you don't have to hand them in. There's a number line assignment, written assignment that has, I believe, 4 problems on it, and the Excel assignment, and I think that has maybe around 3 problems on it also. Do never. Here's the PowerPoints, here's the textbook pages, and so on, like usual. Thursday of last week, we were talking about using the Z-chart, and that's where we left off, and there is one problem related to that lecture from last Thursday, and that is calculating Z and using the Z-chart. So here it is, we're just gonna do it. It says, draw a number line with a bell curve above it, I got it right there. Use the information below to label the 6 numbers. The information below says, let's say that the average number of apples in each cart is equal to, and I'm right down here, right where my pointer's at, 52.3. So I put 52.3 right in the middle. It says with a standard deviation of 5.2. I wrote that right there, 5.2, so I wouldn't forget. Then I added 5.23 times. I subtracted 5.23 times. There's my bell curve. And then it says the instructions say, number 3, shade the bell curve above the number line that represents the probability of X. So we gotta read the question. What is the probability if we were to count the apples in the next cart that just came through that door, and that it would be 55 apples or more? So here we go. Let me grab a color here. 55 on this number line, 52.3 is in the center, 57.5 is here. I'm gonna say, I don't know, right around there, you guys, you agree? Right around there? Closer to the 57 than the 52, right? I don't know, 3 above, 2.5, maybe closer to 7. How about right there? Okay, so there it is. We're gonna go with 55 right there. It says, shade now. How do I shade?
To the right.
Why to the right?
It's greater than.
That's right, because it says 55 apples or more, which means that big extra steps involved in this calculation. So here we go. This is what you would have to do if this were a quiz. You have to show what the question represents all the way to the end. 55 or more is the area under the bell curve. Now you would think that that's darn close to 50%, but this area right here in the center, next to the center, that's a lot. So this is for sure going to be less than 50%, right, according to empirical's rule. Matter of fact, we could probably come pretty close to estimating it if we knew what from -1 over was. It'd just be a little more than that. I don't remember what it is from -1 over off the top of my head, but I think it's something like 50 minus 30, 20 something or something. So you add this little bit to it, that'd be 30 something, maybe 30 something would be the probability from 55 over. That's how you use the empirical rule. You go, okay, I now know that if I'm going to calculate this right or wrong, that I know that if I come out with somewhere around 35% or 32% or 38%, somewhere in there, I'm probably doing it right. And if I come out with something other than that, because that's what the empirical rule told me it would be, then I know I must have made an error. So, here's the whole thing. The instructions say, use the z equation, x minus the mean, then divide by the standard deviation. I'm right up here in the instructions. Then divide by the standard deviation to calculate the z-stat. So here we go. The question's about 55 minus the mean, 52.3, divided by the standard deviation, 5.2, but...
-1.
-1, where's the -1?
Don't you do a -1?
Oh, this is what
Or
it ends up
more?
being. No, this isn't equal -1. This is going to equal
No, not
negative
this.
1, or this is going to equal negative point something. Hang on. But I need you to be prepared for what the real calculation is, because this is actually over the square root of how many carts are we counting? How many carts is in the sample in this question? The next cart says, what's the probability to count the apples in the next cart? How many carts?
1.
One. That's why we're only, because these first few chapters, these first few problems, all our samples are only 1. But as we go in a few weeks from now, our sample size is going to become more than 1, and that's why I need you to be familiar that the standard deviation is going to have to be divided by the square root of that sample size. But for now, it's always 1, so that's why we don't even talk about it. Just divide by the standard deviation. So here we go. 55 minus 52.3. Oh, wait, come on. 55 minus 52.3. We always take what we're being asked about and divide it by the mean. So always, whatever we're being asked about there, the mean's on the right, divided by 5.2, which is going to equal 0 point something. 2.7 divided by 5.2. 0.5 5, 1, 9, 2, 3, 5, 1, 9, 2, 3. But the Z-chart only goes 2 digits to the right. The first column is the first digit to the left of the decimal, which in this case is a 0, and the 2 digits to the right. The first digit to the right is in that first column, and then the second digit on the right will tell us which column to go to. So here we go. 0.5. What should I have for that second digit?
2.
0.52 is what we're going to look up on the Z-chart. Very good. Show your work if you're doing this on the quiz. What would you say the probability is that you're calculating a Z and looking it up on the Z-chart on the quiz? What's the probability? 100%. Who said that? You don't have to take the quiz. You're out of here. It is 100%. 99.9. You never know. Only because I printed it is 100, but usually it would be 99% chance. Because this is one of the most important things you have to learn this semester. We're going to be using this calculation so many times this semester and so many times in 302. This is the key to statistics, is understand this. This is the building block to all, most of the other things. So then it says, look it up on the Z-chart. So here we go. What is it? Positive or negative 0.52? Positive. So I got to go down to the positive. The first column's got to be 0.5, and then the second digit to the right's a 2, so we got to go over to the column with the 2. There's our answer. 0.6985. 85, thank you. 85. There we go. How'd we do? What? Oh. Why do we have to subtract 1? Because the question says 55 or more. Don't forget, what you're looking up on the Z-chart is always for any question or less. And that if any question says or more, you have this one extra step to find the opposite of what you just looked up. So to find the opposite of that, since it's in decimal format, I just put a 1.0 in front and subtract it. So now I'm going to go, let me get the calculator up here. 1 minus 0.6985. 6. Come on.
What if it says if less?
985. Say that again.
What if it says if less?
Unless we're done. There's the answer. If this said 55 or less, we're done. You just look it up. We only do this extra step if it says or more. So now the real answer is equals 30.3015. Change that into a percentage, 30.15%. I said that empirical rule says it should be somewhere around 30 to 38%. We probably did it right? That's where the empirical rule kind of helps out, is that you have a good idea what it should be. So there we do. That's the number line assignment that was due Thursday that you don't have to hand in is now done. Any questions about how to calculate Z? Go ahead.
So the question was, if you were to count apples in the next 2 cards.
In the next 1 card. Oh, if it said 2 cards, is that what you're saying?
Yes.
I don't want to go there yet. You're 2 weeks ahead of us. In about 2 weeks, we're going to go to where there's going to be 6 cards, 30 cards, a whole bunch of cards. But for now, it's all about what's that next card, 1 card. So I don't want everybody on this quiz, you know, to just the sample size is 1, so that you only have to use that standard deviation to divide for now, for this first quiz. Okay, so now let's go to. I want to remind you about something real quick. Factorial. I know a lot of you go, oh, I know what factorial is, but some of us haven't seen it for a long time. If you haven't seen it in a long time, I want to remind you. It means whatever number is being factorial, you multiply it by every number below it down to 1. So, you ready? 5 factorial equals 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120. 5 factorial equals 120, and on the calculator, it looks like this. Let me clear it. It's got a little n with the factorial symbol next to it. So 5 factorial, 120. There you go. Do another one. 4 factorial equals 4 times 3 times 2 times 1. whatever number being factorial times every number below down to 1. 4 times 3 is 12, 12 times 2 is 24, 24 times 1, so equals 24. 4 factorial equals 24. Let me go here. 4 factorial, 24. That easy. We got it? Just a reminder. So now, we're going to go to this text right here. We've already learned how to calculate the variance and standard deviation of data. But what we haven't learned is how to calculate the variance and standard deviation of data that has weights involved. Meaning there's probabilities already assigned to the data. Now this is a little different than regular data, and you got to be able to tell the difference. When you see the data, if there's probabilities involved, there's a slightly different way to calculate that variance. Standard deviation is the same, square root the variance. That stays the same. But the variance calculation is different when there's weights involved. So here we have, hey, here's the data, 0, 1, 2, 3, and here are the weights, which always add up to 100% or 1.0. 30%, 50%, 15%, and 5%, it's 100%. Each piece of data. Your reaction to find the mean, you're going to be asked, hey, what's the mean of this data? Is to say, oh, 3 plus 2 plus 1 plus 0 divided by 4. Don't do it, because there's weights involved. Instead, you multiply each piece of data by its corresponding weight, then add the results. So, here we go. 0 times 30%, I'm running out of space, aren't I? 0 times 0.30 equals 0. 1 times, what's the probability of that one? 25? 0.50, 50% equals 1 times that is 0.50. 2 times, what's that one? 0.5. 1.5. 2 times that equals, that'd be 0.3, I think. 0.3. Does that sound right? So we got to calculate it out. 2 times 0.15. 3 times 0. What's that? Corey? Got relying on Corey. Someone else.
0.05.
0.05. 0.05. 3, that would be 3 times 5. That's 0.15?
Yes.
0.15. So there's that one. And then the last one, is there a 4 involved?
No.
Oh, that's it? We're done? I can add these up now. As long as these are correct. Someone correct me if I'm wrong anywhere. Everything's
No.
okay so far? 0.5 plus 0.3 is 0.8 plus 0.15 is 0.95. Does that sound right? 0.95. 0.95. Let's see what the result is here. Hang on, I jumped ahead. Hang on. This one's different. We're not doing the expected value on this one. Don't be wrong. If this is exactly like a problem that you have to do the expected value, and yes, you do exactly what I just showed you. But this one's asking you to use the percentages to answer questions specifically about the data. For example, this data represents a realtor, how many houses were sold per month, unusual. Some months there's 0, 30% of the time, 0 houses are sold, 50%. So you have to be able to analyze the sentence that you're about to hear and add the correct probabilities. Which probabilities, there's 4 of them there, 30%, 50%, 15, and 5. Which ones are involved when you hear the statement, what's the probability that the realtor does not sell any homes in the next 1 month period? Say it again. 30%. All you have to find is one number that represents selling no homes per month, which says 0 homes, 30%. Okay, C. What's the probability the realtor sells at most 1 house in a month? At most 1 house. What numbers are involved?
30 to 50%.
30 and 50%. 0.30 and 0.50, because the 2 numbers that represent at most 1 house would be 0 and 1. Do one other one real quick. What's the probability the realtor sells at least 2 homes in the next 1 month period? What probabilities are you involved?
15
15 and what?
30 and 50.
30, 15, and 5, because it says at least 2 houses. That would be just the 15 and the 5. 2 and 3 houses represent the words at least 2 houses. That'd be selling 2, be selling 3. Okay, now let's take it to your homework. You ready? Whoop, where'd it go? Here we go. The first question in your homework says, first of all, this is probabilities of grades. 0, 1, 2, 3, and 4. 4 representing A, 0 representing F. Here's the probabilities. You tell me what numbers would be used to calculate what's the probability that a student receives a letter of grade C or better. What probabilities are involved?
0.32,
0.32,
0.28,
0.28, 0.18. C or better. You had to look for the C, B, and A and add those up. So 32% plus 28% plus 18%. Let me look at the answer. 78%. There they are. The next one says, what's the probability the student receives a letter grade of C or worse? I hear 0.32, 0.14, 0.08, C or worse. 0.32 plus 0.14 plus 0.8, that represents C or worse. Let's see if we're right. 321408 is 54%. 54% getting a C or less. 78% is getting a C or above. The last question, what's the probability the student receives a letter grade between D and B? The number one question I get on this is, do you include D and B in that? Yes or no? I see a yes. Yes? You are correct. You do include them. So what percentages would involve? I hear 0.14. I hear 0.32. I hear 0.28. Let's check and make sure. 0.14, 0.32, 0.28. Okay. This was easy, right? Now, since I taught you this already, find the expected value of this data. This is no different than what you saw. They have probabilities next to them. The probabilities add up to 100% or 1.0. So let's do the math on this. Oh, I got it right there. Here it is right here. 12 times 0.28 plus 10 times 0.32 plus 6 times 0.40. Let me scroll up. I don't want you to see the variance yet. Hang on. There. All right. So there you go. There's how to find expected value. This could be on a quiz or a final exam. And if it is, don't make the most common mistake of adding 12 plus 10 plus 6 divided by 3. If this were just the data with no weights, that's exactly how you find the mean. 12 plus 10 plus 6 divided by 3. But because the weights are there, you got to multiply each number by the weights, then add them up. And no divide by anything. You got to multiply them by the weights, then add them up. Notice the weighted is 8.96. Now that we have the mean, we do everything the same as we did before to find the variance. 12 minus the mean of 8.96. What's the next one? 10 minus the mean of 8.96. And 6 minus the mean of 0.896. Matter of fact, let me show you here. It's so much like finding the variance with regular data after you pass the first step, but then you gotta use the weights again on the last step, coming up on the second to last step, excuse me. So, let's look at this example. And then we'll go back to that homework problem and finish it. So I want you to see it all the way through. Here's the data, 0, 1, 2, 3, 4. Look at it, it has weights involved. If it asks you to find the mean, it really means expected value, or expected value is the word for mean when there's weights involved. And sure enough, the weights, 40%, 25%, 20%, 5%, and 10% add up to 100%. Multiply straight across, 0 times 40%, 0. 1 times 25%, 2 times 20%, 3 times 5%, and 4 times 10%. Now add up the results. You found the mean of weighted data, 1.2. Now we're going to subtract each one of the x's minus the mean or expected value of 1.2. Let's go to the next. 0 minus 1.2 is negative 1.2. 1 minus 1.2 is negative 0.2. 2 minus 1.2, 3 minus 1.2, 4 minus 1.2. Sounds familiar. Subtract the mean from every number. Sounds familiar. The next step would be in regular data to square each one of those subtractions. Same with weighted data. Now that we subtracted the expected value, you square each result. Negative 1.2 squared, 1.44. What's the point of squaring?
Remove the
Get
negative.
rid of the negatives, exactly. Negative 0.2 squared, 0.04. 0.8 squared, 0.64. 1.8 squared, 3.24. 2.8 squared, 7.84. Now here's where it's different. Because at this point, you would add the squares and then divide by the number of pieces of data minus 1, right? Remember that from a week ago? But this time, because there's weights involved, you take each square, multiply it by the corresponding weight. The first one, 1.44, well, look back at the original piece of data, 0. It had a weight of 40%. So we're taking that square times that weight. I want to make sure everybody sees where these weights came from. They're the same weights that were with the original data. So 0 has 40%. So if you go straight across, we took 0 minus the mean, then we squared that mean. Now we're multiplying that square times the 40% again, because that was the weight for the 0 that we started with. The next one's being multiplied by 25% because that was the weight for the 1 in the original data. The 0.64 is being multiplied by 20%. Again, that was the original weight. 3.24 times 5% and 7.84 times 10%. The original weights are being used in the same order as they were presented with the data. Nothing changed. The only thing that's changed is we're now multiplying by the weights. Notice now, we add up the results and we do not divide by n minus 1. Because when we multiply by those weights, that is the replacement of dividing by n minus 1. Let me show it again. We took each square, multiplied by the corresponding weights, here's the results, and then we added those results. There's your variance, right there. Add those results and that's your variance. You don't have to divide by n minus 1 because of the weights. You could have either one of these types of variance calculations on your quiz. Hey, it could be raw data or it could be weighted data. It'll say calculate the variance and you gotta know which way to go here. So that's why I wanna make sure to point this out, please.
So since we have the weighted data, it does not equal 0?
You're right, the subtractions don't equal 0. I don't remember if you add up those subtractions, they equal 0 or not. Did anybody add them? No, because there's no, well, what, do they? They don't? Probably because of the weights, yeah, for sure. You're saying negative 1.2, negative 0.28, and 1.28 don't add to 0? Yeah, because of the weights, for sure. So what's the variance? You know what, I forgot. You guys probably didn't hear her question. We were talking about the second column, the negative 1.2 and the negative 0.2. If this were regular data, after you subtract the mean from each piece of data, that column usually adds up to 0. That way you know you did it right. But with weighted data, those subtractions won't add up to 0. The negative 1.2, the negative 0.2, the 0.8, the 1.8, 2.8 don't add up to 0 with weighted data.
How do we determine if weighted data?
I'm sorry?
How do we determine if weighted?
Because there'll be weights right next to the data. Like, the question will look just like your homework. There's the variance, by the way. The only last step you have to do here is take that variance and square root it to get the standard deviation, just like with regular data. But now, look at this homework problem. This is how you know it's weighted data, right there. 12 has a weight of 0.28, 10 has a weight of 0.32, 6 has a weight of 0.40, and it will say, calculate the variance of this data with, or maybe even say weighted data, I can't remember. Should I pull out the quiz and look?
Yeah.
Do you think that's on it?
Yeah.
Well, who knows? That could be just Josh. But if there is a weighted data problem on there, you'll have the raw data with their weights right next to it, and that's how you know it's weighted data. And if it doesn't have the weights, it'll just be the data, and there'll probably be more than 3 of them, you know, because it's just the data, but it will be just the data with no weights. So, everybody get it? Can you do the variance for either one? Okay, all right. Let's look at this now. 12 times, we found this, the 8.96. Now we take each one of them and subtract 8.96, just like that example. And once we get those subtractions, we're gonna square them. So let's look at the answer here. There it is. 12 minus 8.96 is 3.04. 9, whoops, square of the, okay, then I squared it. 9.2, so I took the 3.04 and squared it. Next one. 10 minus 8.96, 1.04, now square it, there's the square. 6 minus 8.96 gives you a negative 2.96, now square it, there you go, got rid of the negative. Now look at what I did. I took each one of those squares and multiplied them by the corresponding weights, the 0.28, the 0.32, and the 0.4. Here's the step you won't see with regular data. I took each one of the squares, multiplied by their weights, then I added the results. There's our variance, 5.4384. The added results from those squares. I'd have this open right in front of me while I'm taking the quiz. So to refresh my memory how I got to that variance when there's weights involved. There's every step right there. And then, what do I do to get the standard deviation? Square root the 6.4384. The standard deviation, 2.5374. Just like the example. This is almost too easy. I'm not even hardly challenging you guys. I don't even know what you're doing here. I'd skip if I were you. What? This is not, the questions posted, the answers are being posted tonight.
Okay.
The questions are posted, the answers will be right below them in the assignment folder. All right, now the question for you is, can we find the expected value with weighted data? That was number one. Can we find the variance when there's weighted data involved? That's number two. Can we find the standard deviation? That's number three. Everybody's shaking their head yes, so I guess that means yes. I don't see anyone raising their hand. Let's go to, let's see. We're going to slide 14. Okay, you ready? It's about to get hard a little bit. Whoops, did I say that out loud? Whoops. Binomial probabilities. Binomial probabilities. The hardest thing to do is recognize them. That's why it's separate from all the other ones you're about to learn after this quiz gets over with. You're about to learn normal probabilities, Poisson probabilities, exponential probabilities. Binomial is so hard to recognize that it's all by itself on this quiz. So you should be able to recognize it. The only challenge you're going to have is recognizing it on the final exam. But you'll know that you're reading a binomial on this first quiz. What percent chance is there a binomial problem on this first quiz?
100%.
I usually would say 99, but it's printed. It's printed this time. So I'm going with 100. All right? It's an experiment that consists of a sequence of n identical trials. It's how many trials. It will say something out of, we're randomly selecting 5 employees, and what's the probability one of them will do this or that? That number of how many we randomly selected is the n, the identical trials. These are employees all working the same job. We randomly selected them. We're going to watch them for the next 12 months and count how many of them are no longer with us, or something like that is going to happen. And what's the probability 1 out of those 5 are no longer with us? Or what's the probability 2 or more, 2 or less? Something like that. 2 outcomes, success or failure. That example I keep saying about picking 5 employees and maybe we're measuring whether they're still with us in 12 months or not. Either they are with us or they're not with us. That's what it means by success failure. There's only one possibility or the other. We're measuring it based on either we're measuring those who are still with us or we're measuring those that are no longer with us. We call whatever we're measuring the success. Don't take it literally success. Success means whichever one you're measuring. So if the problem says, what's the probability 2 of them will no longer be with us, we're counting how many will no longer be with us. We're not counting how many will still be with us. We're counting how many will no longer be with us. That's success, the success we're counting. Losing my voice. Let's get to the example. I always find it, oh, wait, the equation. I love the equation. Look, I put it up here. There it is. This is the equation. You've got to have this in front of you while you're taking the quiz. There's only 3 numbers up there. There's only 3 numbers. The given probability in the question is your P. Let me repeat that. The given probability in the question, in the problem, is your P. The number in the trial, hey, we're going to pick 5 employees at random. That's your N. The number in the trial, however many we're picking randomly, is your N. The number being picked randomly. And then the number the question's about, what's the probability of this many or that many, is your X. Whatever the number is that the question's asking you about. The number the question's about is your X. That's it, 3 numbers. Here's your factorials. All right, I'm going to go back and read this, and then before we look at the answer, we're going to go and see, I want to make sure you understand where the points are on this. The points, the biggest part of the points is that you look at that story and you pick the 3 numbers out and set them up correctly in the spots that needs to be in this formula. There's most of the points right there, is in the setup. I know all of you can do the algebra once you get this set up and give me an outcome of the result, and there's points in that too, but the bulk of the points is that you took that story, you figured out the 3 numbers to pull out of it, and to plug and set that up correctly. That's what I'm staring at when I'm grading it. Go ahead.
You said that P represents the probability that they give us, that you're gonna give us on
Yes,
numbers.
the P is the probability that will
What
be
do
given
it-
to you in the problem.
And N and X, what do they represent?
X is whatever you're being asked the question to find the probability of.
Okay.
The question, the number you're being asked to find the probability of, 2 or more, 3 or less.
Okay. And N.
And N is however many are in the, that was randomly selected to measure.
Okay.
However many were randomly selected to measure. Let's read this first problem, it'll help make sense, then we're gonna go back to the formula. Look. Evans is an electronics company. They're concerned about low retention rate for employees. In recent years, management has seen a turnover of 10% of hourly employees annually. Thus, for any hourly employee chosen, management estimates that about 0.1 of those people will no longer be with us. So let me make sure you understand this. Management is saying we usually have 10% turnover, so if we went ahead and randomly selected 10 employees, we expect how many of the 10 to no longer be with us in a year from now? One of them. 10% of 10 would be 1. Get it? All right, you got it. Now, the question says, choosing 3 hourly employees at random, what's the probability that 1 will no longer be with us? Here's the formula. Here's the formula. Let's start with this top N right here. It represents how many is in our randomly selected group, and how many are we randomly selecting? 3. There it is. Let's go with this X. X represents the number you're being asked to find the probability of. We're being asked to find the probability of how many out of the 3?
1.
1. It says, what's the probability that 1 will no longer be with us in a year from now, right? So now we know what N is here, that's a 3. We know what X is here, that's a 1. So let's go like this, let's put the factorial, put the factorial, put the factorial. 3 factorial, 3 times 2 times 1 is 6. 1 factorial, 1, 1. By the way, what's 0 factorial?
0.
No.
1.
Someone say 2? 1. I know that's a weird one. That's 1 factorial is 1, but so is 0 factorial. It's the only weird one. 0 factorial equals 1. If you didn't know it, put in your notes, because this comes up to 0 something a lot. So 0 factorial equals 1. Now, 3 minus 1 is 2, so 2 factorial, this is 2 factorial, which equals 2. So this number is a 2, 2 times 1 is 2, 6. 6 divided by 2, there is this whole part on the left side turned into the number 3. Look at that, it's that easy. Just by using the 2 numbers. It said, the question said, we're gonna randomly select 3 employees, we're gonna watch them for the next 12 months. What's the probability that 1 of those 3 are no longer with us in a year? 1 in 3. Now, what was P? What was the given probability in that question?
10%.
10%. Management believes there's 10% turnover in this company. So there it is, 0.10 to the probability of X. What was X? 1. So right there, 10% to the 0.10 to the power of 1 is 0.10. That's done. 1 minus 10%. 1 minus 0.10 is 0.9. Right? The opposite of 10% is 90%. 0.9. To the power of N minus X. 3 minus 1. So this is 0.9 squared. I want you to show you on here. There it is. 3 factorial on top, 1 factorial times 3 minus 1 parentheses factorial on bottom in the new denominator. Then it says 0.1 to the power of 1, 0.9 to the power of 2. We do the math on that. 0.9 squared is 0.81. So this ends up being 0.81 times 0.1 times 3. Put it right there. There's our answer right there. 3 times 0.81 times 1. And you can multiply that in any order and get the right answer, which will be 0.243. Go ahead.
Is that enough work, or do you have to show us which one on the board?
Is this one?
Is that enough work?
No, that's not enough work.
Okay.
Is it? Hang on a minute. That's kind of enough work, yeah. The thing is, only because those numbers are so small is that enough work. But if that were like 5 factorial, Yeah, see how it's not showing that 3 factorial is a 6? I'd like to see that that's a 6, that 3 factorial. And notice the 3 minus 1 is 2 factorial. Nobody's writing down, I don't see the 2 factorial on there, so I would say no, that's not enough work. Good
What's
question.
that 5 factorial? They have to show that we have 5 factorial.
No, but you gotta show the 120.
Okay.
Show that it equals 120, yes.
But when you're doing level solution, how high is the factorial gonna get? Because I know factorial is big really fast.
Say that again, how high will it go? Because you know factorials are big, but what do you mean how high will it go? You mean, could I have given you a question that could be a 10 factorial, where you gotta go 10 times 9 times 8?
Yeah.
I realize that you have a limited time on this quiz, so I'm not gonna write a problem like that.
In the future, I'm saying also.
In the future?
Yeah.
Yeah, but here's the thing, you're about to learn how to use Excel to solve them, so if I have one with a 10 factorial, it's probably one you're solving using Excel instead of manually. My manual questions, solving it manually, are numbers that you can handle in a short period of time. I would say they're usually like 5 or below, so 120 might be the highest. How we doing? Let's do the homework one, ready? Now, this is about the setup. I want to give you 60 seconds to set this up after we read the problem together. It's about the setup. All I'm asking you to do is what number goes where. Have this all ready to go. What number goes where? Okay, so let me get to it here. It's right here. Oop. I don't want to give away the answer. There, right there. Here we go. You've been asked by the president of your company to work and calculate the probability that one employee out of randomly selected 4 employees will leave the company in the next 12 months. Oh, this is almost exactly like the example. This class is too easy. Let's take a nap. You're all over that. So 4 employees. So let me read it again. Calculate the probability that one employee out of randomly selected 4 employees will leave the company in the next 12 months. Traditionally, the company has a turnover rate of 12%. This means that about 12% of the employees leave each year, and the company spends money to replace them. Calculate your answer manually using the formula and using your detailed work. Example, Chapter 5, PowerPoint sample, slide 19. Rounding is acceptable as long as you round correctly and leave at least 4 digits to the right of the decimal. All I'm asking right now is for you to set it up. Figure out what 3 numbers you have to use and get it set up. And if you get this set up in 60 seconds, and then I set it up, and it's the exact same setup you have, you should be able to sleep well the next 2 nights for this quiz. Because I would say this is probably the most points on the quiz right here. If you can set this up. Look, if people are done already. People are done already setting it up, or not even doing it, one or the other. One or the other. Here I go. Hang on, let me get rid of the numbers that are here so I can just put it right above and below this formula. In fact, I don't know the answers. I don't have it memorized. So what I'm gonna do is I'm just gonna let you tell me. Ready? What should I put for the end? 4 right here. Is that everyone agree?
Yeah.
Okay, so I got a 4 down here also. 4 minus what's the x?
1.
I got a 1 here, I got a 1 here, right here, right here. So I got 4 factorial on top, 1 factorial on bottom, 4 minus 1 parentheses, then factorial on bottom. Does that sound right?
Yeah.
What's the p?
0.12.
12%?
Yeah.
Yeah.
0.12?
Yeah.
Okay, 0.12 to the power of what? 1, x is only a 1? Well, that's pretty easy. There's that. 1 minus 0.12, which equal, it doesn't matter, it's all about the setup. In the parentheses in the numerator, or in this exponent though, would be what?
4
4 minus 1? Just like that? Is that what you have for setup?
Yeah.
Oh, boy, I don't even know why you would study. There's no reason. There's no reason to study. But, if it takes you a long time to find whatever you're, well, let's look real quick, see if we got it right, I forgot. 4 factorial over 1 factorial times 4 minus 1 factorial times 0.12 to the power of 1 times, parenthesis, 1 minus 0.12 to the power of, parenthesis, 4 minus 1. Very good. But it's all about how fast can you find that to help you remember how to set it up on the quiz. That's what it's about.
So can we run, 2.327 to 2.33?
No, it's, the problem says go at least 4 digits to the right of the decimal.
And one more thing, so what if they ask us for probability that one and more?
Okay, that's a good question. This, where is it? This, right now, it's asking for the probability of 1 employee, exactly. And he's saying, what if it said 1 or more, I think is what you're asking, or 1 or less even is what you should also be asking, which is what we're doing. Here's the deal. You ready? With uniform, I'm sorry, not uniform. With binomial probabilities, you are manually calculating the answer for 1 number only. That's what's so weird about it. And if this said, what's the probability that 1 or less employees out of a randomly selected 4, we have to do this all over again, but this time, X is a 0. Yeah, what's 0.12 to the power of 0? What's any number to the power of 0? 1, isn't it? Any number to the exponent of 0 is the number 1, so that's going to turn into a 1. And then this is 4 minus 0. So we didn't calculate the whole thing where X is a 1, get an answer, calculate the whole thing again with X is a 0, get an answer, add the answers together, that's the probability for 1 or less. Now, if it said 1 or more, or more than 1, that would be 2 or more, right? I don't want to do the math all over again for 2 or more. So I'm going to take the probability for 1 or less, these two added together, and subtract it from 100%, and I found the probability for 2 or more. Because they'll always add up to 100%, the less or the more. Okay, now, what if this said, you have been asked by the president of the company to work and calculate the probabilities that, hang on, man, I almost want to say it, 1 or more. Probability that 1 or more employees out of a randomly selected 4 employees will leave the company in the next 12 months. 1 or more. You don't want to do this calculation for the number 1, then the number 2, then the number 3, then the number 4, and add them all together. That's too much work. So you would do the opposite. You would say, what's the opposite of 1 or more? Find the probability for the opposite and subtract it from 100%. You only have to do the calculation 1 time because the opposite of 1 or more is just 0. So you would do it 1 time with the number 0, then subtract it from 100%, and you found the probability for 1 or more. Now, here's the deal. If I'm asking you to do it manually, I'm probably going to ask a question like 1 or more, or I'm going to ask for a probability of exactly just 1 number, not a more or a less, just 1 number, because then you only have to calculate it once. If I'm asking a question where you're going to have to do it multiple times, where I'm asking for, let's say, 2 or less, that means you'd have to do it for 2 and for 1 and for 0 and add them together, I'm probably going to ask you to solve it using Excel. That's too much work. It would take too much time to have you do it manually. So if I'm asking for 2 or less, like this question, hang on. I don't want to show the answer yet. Hang on, that's why I'm going slow. Write the Excel function equation and result just as if you were typing into an Excel spreadsheet that uses the binomial probability Excel function to calculate the exact same result you just calculated manually above. All right, are you ready for this? This is how easy this is. With Excel, with Excel, you just need those 3 numbers, and you enter them in. Equals binomial dot distribution, or you can leave the dot off. I always leave the dot off, but you can use the dot if you want. Everybody see where I'm pointing? Binom dot dist, parentheses. X is the first number. Whatever you're being asked to find the probability of, or less, or of, or more, or just of. So, in that first problem we did, the X was a 1. That would be the first number in the parentheses. The second number is the number of trials, the randomly selected number, which was 4 out of, if we randomly selected 4 employees, that's the second number in the parentheses. How many is the randomly selected trials? How many of them? If we randomly select 4 employees, what's the probability that 1 will no longer be with us? 4 is the second number, 1's the first number, because you're being asked the probability of 1. Then, the next number is the percentage probability given in the problem. In this case, it would have been 12%, 0.12. That would have been the third number in the parentheses. The last number in the parentheses is if you're trying to find the probability of exactly that first number, you would use then a 0 or the word false on the end. But if you're trying to find the probability of that first number or less, you put a 1 or the word true on the end. That's telling Excel, do this calculation for every number. So tell me what this is saying right here. This says, find the probability of 15, exactly 15, out of 15, when the probability is usually 80%. Let me repeat that. This right now is saying, find the binomial distribution probability of 15 out of 15, and by the way, that's exactly 15 out of 15, when the probability is usually 80%. Now, let's say I change this to a 1, which is like changing it to the word true. Hang on. A 1. There. Now, this is saying completely something different. You're now telling Excel, find the binomial distribution for 15 or less out of a possible 15 when the usual probability is 80%. Notice the first number now is 15 or less because I put a 1 or the word true on the end. You're telling Excel you want multiple multiplications done in one equation. So Excel now is going to find the probability for 15 out of 15, 14 out of 15, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0, and add them all together, and it's going to give you that probability right there, which should be 100%, 1.0. Look at that, 1.0, because it's every number. Now, here's the hard part. Are you ready? Wait. So look at where my pointer's at. Tell me what to change that first number if this and this last number. If this question said, we're going to randomly select 15. What's the probability exactly 14 or blah blah blah? And we usually have 80%. What changes here? What numbers change in those parentheses? Let me repeat it. So I heard it. Who said it? Say it again. X changes as what though? 14. Because I said, what's the probability that exactly 14 out of the randomly selected 15? What else changes? That's right, at the end. Instead of a 1, that becomes false or a 0. Same thing, false means 0. Now, this is finding the probability of exactly 14 out of 15. Are you ready? I'm going to change it again. We're randomly selected 15. The probability is 80%. What's the probability that out of that 15, 13 or less are going to be da-da-da-da-da? 13 or less. So what do I change?
13.
The 14 turns into what?
13.
13. Anything else? The 0 turns into a 1. Okay, you get it. You can answer this now for any number or less, correct? Hang on, let me change the wording. I want to make sure you get this. What changes in this? We're randomly selected 15. The probability is 80%. What's the probability that no more than 14, no more than 13 are a success? No more than 13 are a success. What changes? That was a trick question. Because nothing changes. Right? No more than 13 or no more than 13 means 13 or less. They mean the same thing. You gotta, it's the word. The word. What does it mean? I'm not going to try to be that tricky. I'm not going to, but it could be. So just so you know, I'm going to do one more, 2 more. I got to do 2 more. Oh, again, I think I'm going to answer it with these 2. Ready? Ready? First, I want to say, out of 15, the probability is usually 80%. What's the probability there'll be 10 or less? 10 or less. What changes? The first number turns into what?
10.
10, so hang on. And then the last number turns into what? That's right, stays as a 1, because 10 or less, 10 or less. Are you ready? What's the probability there'll be 10 or more? 10 or more. Almost. Right? Here's the weird part. There'll be a minus, 1 minus in front, but in the parentheses have to be the opposite of what's being asked. So let me say it again. Usually there are 15 in the sample. Our usual percentage is 80%. what's the probability there'll be 10 or more? 1 minus in front, but in the parentheses, that first number has to be the opposite of 10 or more. What's the opposite of 10 or more?
10 or less.
No,
No, 9 or less.
9 or less. 10 can't go both ways. 10 or more, the opposite's 9 or less. So I gotta change this number to a 9, even though the question's asking about 10 or more. This is where people get lost, right here. So let's do another one. This is the hardest part.
So it has to be a 1 minus the binomial?
If any question that says or more, you gotta have that 1 minus in front. The hardest part is what's the first number in the parentheses when the question's in or more. Let's try another one. You ready? We're gonna randomly select 15 employees, and we usually have 80% success. What's the probability we'll have 12 or more in this next group? So what about the 1 minus in front? Does that stay?
Yes.
Does the 1 on the end stay?
Yeah.
What number goes in the parentheses for, did I say 12 or more?
11.
11. The opposite of 12 or more would be 11 or less. So that's the hardest part of binomial distribution, is an or more question where you've got to use Excel, because that first number has to be the opposite of logic. And the rest of the semester, other than Poisson, you're always using whatever number's being asked for as that first number. Only binomial and Poisson, on this first quiz though, binomial is the only one on this first quiz where you gotta use the opposite of what's being asked for on an or more question. I wanna try another one. We're gonna have a sample size of 15 randomly selected. We usually have 80%. What's the probability there'll be 3 or more? 1 minus in front, a 1 on the end. What's the first number though for 3 or
2.
more? 2 or less. 2 or less. The opposite of 3 or more. I gotta use a 2 for that first digit then, because it's an or more question. And I gotta use the opposite. How do we feel? Okay, now let's go back to our homework problem. Let's solve it. Because this was an or more question, I think, wasn't it? Hang on, how are we doing at time? Just perfect. Whoop, whoop, whoop. Don't look at the answer. The question says to write an Excel equation for above. And the Excel equation above says, randomly select how many employees? 4 employees. Right, so there's our 4. What's the probability there'll be 1 employee or less or more? Oh, exactly 1. Exactly 1. Here we go. Equals binomial dot distribution. I don't know if I spelled it right or not. Did I? Binomial distribution parentheses. We're writing it for exactly 1 employee out of 4. We usually have 12%. What's the first number? 1, comma. What's the second number? Come on, I can't hear you. 4, thank you. What's the next number? 0.12, 0.12. You could also write it as 12 with a percent symbol. You could also write it as 0.12 without the 0 in front, and it will correct you automatically. Any one of those will work. Comma, what's the last number? What is it? I hear 0 or false. I'll put a 0. I like using the numbers. There's your answer. Now, if this were a quiz question, there would be one last step. Did we put 14.120? We sure did. On the quiz, I expect you to write that out manually. Let me get rid of this so you don't get confused. There you go. Write that out manually, and then I expect the result on the quiz. So you need to have Excel ready to go, and Mac users, some of you don't have Excel on your Mac, so be prepared.
Do we bring our own computer?
Yeah, you have your choice, either this one or your own, but if you have a Mac and you don't have Excel, think about it before you get here, what to do.
I have a financial calculator and it only runs 2 decimal points.
You have a financial calculator and it won't go to 4 decimal points?
I don't know how to set it that way.
You don't know how to set it that way?
It's only
I
2
wouldn't use
decimals.
it. Use the calculator on the computer. The computer calculator is so good. You're gonna use your computer or this computer when you take your lab? Yeah, the calculator on Windows is perfect. Set it to scientific though. Let me show you the calculator on Windows. You can go up here to the left and you can set it to standard scientific graphing. Go to scientific. It has everything you need for this class.
And you don't need Wi-Fi for it?
You gonna need what?
You don't need Wi-Fi to use it?
No, you don't need Wi-Fi to use that. Yes.
But he can't use
You were talking about setting up our pages for the quiz. How would you do that?
Setting up your pages?
Yeah, like having specific PowerPoint.
Yeah, yeah,
Stay zero.
I don't know if you're gonna have it on a thumb drive, or you're gonna get here early and get it all off the canvas, but I would just have them all open. I would have them all downloaded and open. Don't forget, don't open PowerPoints in Canvas. Download them and open them, because when you open them in Canvas, some of the graphics don't show up. You don't see some of the equations. Download it, where if you're gonna do it before the quiz starts, get here early, download it off of Canvas and open it up, have everything open. So you're just clicking at the bottom on whatever it is you need. Maybe organize it in some way, and then I'd have a piece of, you can't have a piece of paper though. I'd have a picture of a piece of paper that's kind of an index telling me here's a subject name, which PowerPoint to go to, which slide number, which page to go to from the book, which answer of the homework, which answer of the in-class assignment related to that subject. I'd have every one of the subjects and where to look for each subject. And you look down at a problem, you go, oh, this is binomial. You look at that page, binomial, PowerPoint chapter 5, slide 17, you go there, oh, there's the formula, or something like that. You need a system to find whatever help you're gonna use fast, so you're not spending all day searching. Wait, it was his question than yours, because I never got
I
to
was
his
gonna say,
side.
he can't use two computers though on that.
You can't use two computers, is that what he was asking? I didn't get that out of that
No,
question.
because you said you could use the,
Labs or your own, but and I'm giving a warning to Mac users to figure it out beforehand how to get Excel on your Mac, because you got Excel questions that you need to put the numbers in and give the results. Now,
So for this example, if it said that it should be more than one, more than one.
more than one, yeah.
So we would.
You
put
ready?
So we put 0 instead of 1.
He's saying in this example, if this said more than one, here we go. More than one or more? One and more?
One or more.
He wants to go one or more. What's gonna change? This is one, this right now is exactly 1 out of 4. One or more, what's gonna change?
1 minus binomial.
1 minus in front,
It's gonna
1
be
minus
0.
there. What else is gonna change?
Instead of the 1
is the
0.
first number.
Instead of this 1 or more means the opposite. That changes to a 0. Is that what you meant? What about this?
What about this? That's what I was asking.
It's gotta be a
That's
1.
gonna be 1.
Because it's gonna be or more or less. This is only a 0 if you're asking for the exact probability of a number.
So
A more or more or an or less, you gotta have a 1 on the end.
I just didn't understand what is the 1 at the end. What
That's telling the computer that this is an or more or an or less question. If it's a 0, we're trying to find the probability of 0 out of 4 if that's a 0. But if that's a 1, that's now, with the 1 minus, that's now 1 or more. You're finding the probability for 1, 2, 3, and 4 and adding them together because you put a 1 on the end.
if it was or less?
If it's 0 or less, or what do you mean, 1 or less?
1 or less.
Okay, 1 or less.
Then we would remove the
Let me
1
get rid of
minus.
that. Let me get rid of that, make that a 1 again, and now that's 1 or less.
1 or less. Okay.
Because now this is gonna find the probability for 1 and 0 because of that 1 and add them together for you. If this is 0, it's exactly 1, but because it's a 1 on the end, that's 1 or less.
Okay. Thank you.
All right, you ready for the in-class? We gotta get going on the in-class. I'm gonna finish passing these back, and then it's all about whatever you're gonna do to get organized, get ready for the quiz on Thursday. Is the quiz really on Thursday? Are we really there? All right, just checking. Here's the in-class.